Cool. Let's get going for today. It sounds like most of you got into the storage chapter, or a good number of you, but maybe didn't quite understand what was going on or how it was working. I think that makes perfect sense. It didn't really explain how local storage is working or what's going on. It just talked about integrating into our app and used some hooks that already existed that we either didn't write or sort of glossed over when we wrote them because they were pretty complex. So some of that we'll come back and talk more about. But I think the first thing to do is to just talk more about just local storage at a base level and how it works. And we can even show some examples of running some local storage code or accessing local storage directly so that it'll hopefully make more sense. So I don't know if anybody pulled up the developer tools after they got this app running. It was sort of mentioned in the chapter that there's really great developer tools in, I can't remember where it mentioned it, but great developer tools in Chrome. Said the resources tab, which is actually the application tab now in the newest version of Chrome. But it can show you a lot of information about this sort of information for your website, including things like local storage. So if you finished implementing the local storage and maybe you navigated around the application a little bit, then if you go to the application tab inside of your Chrome developer tools, you should see a key called app and then a value, which is just this long string. And that'll vary based off each person's system. Is going to be a little different because each ID is different and whatever actual values you have in here. But this is where your browser is storing that information. So this is sort of, this is a visualization into your browser storing that information. The other cool thing now is if you change values after we've made this change, like change it to do the laundry, once you finish this chapter, then if you say refresh this page, instead of going back to whatever you had before, or let's add another task. Grocery shopping. If we refresh, everything should show up in our list here, as opposed to returning back to whatever the defaults were that we were setting before. So that's the goal of what we were implementing this whole time. And I went ahead and had it also keep these style changes or theming changes that we had, which was trivial to do, and I'll show that as well. So that gets maintained between sessions as well. So let's talk more about what's actually going on here and the low-level browser behavior that we're using. And then we can switch back over to the chapter and step through some of the code that we wrote in this chapter, or copied and pasted, if you will, and talk about how that's working and what it's hooking into. So this local storage capability, this is part of just your browser, built right into your browser. So if you did window.local storage, for example, you get back the local storage object for this page. This is a capability built into the browser, modern browsers, so that you can store things for websites, like small bits of code. The way people used to do this, if they wanted to store something client-side before this local storage API existed, was they would use cookies. And so you may be familiar with hearing about cookies, which this page isn't likely to have. Okay, just a C9 live user click-through one. So there's a cookie there. But one of the issues with cookies is there's a lot of restrictions on how to access them. It's a really complicated interface. And the original intention of them were little bits of information that you wanted to send back to the server when you talk to it. So they're not really capable of storing large chunks of data. They're very limited in what they can store. They're very limited in the way they store stuff and how you access it. Unlike that, cookies, local storage or session storage, which are both very, very similar things, give you the capability to store things using a more standard approach. So we can do this again. I wonder if it's going to let me. All right, lets me do it without that. So local storage is just an object, but it's a built-in object into your browser. And as an object, it's got properties and methods just like any other object can have. So there's constructor, there's a clear, there's get item, key, remove item, set item. We go back to our documentation or our chapter, we have, oh, look, it was saying there's a get item, a remove item, and a set item type values. So what he's writing about here isn't something built into the application that we wrote, but leveraging something directly from the browser. So let's go ahead and do that. If we get an item out of local storage, what we need to give it is the key. And we stored this stuff with the key of app. So if we give it a string saying our key is app, what we should get back is the value that we're storing in that app key in local storage. And if we want to add something else to our local storage on a browser for a web page, you can do a set item. And this took 2 arguments. It takes your key. So let's say we want to change our key. We want to store something in, I don't know, we'll just call it props. And then we'll just store the value, no custom props, just a string. And what you see right there is just, we've gone ahead and added another key value pair into our local storage. Props is the key, no custom props is the value, it's just a string. So this is just a very, at its most basic level, this is like the most basic API that exists or way that you store and read from any place that you're storing data. Is you can store stuff with some sort of key and get back that value and read it out. And that's really all that local storage gives you, other than the ability to like remove your item. So we can go back here now and say, oh, we didn't actually want to store our props, so we can remove it, giving it the key name, and it gets deleted. And the higher level ability to clear everything if you want to. And when you do that, though, like our application, for example, now, we don't have any tasks that existed there. So we have to go recreate them because there was nothing stored in local storage for our tasks to read out, because we quit pre-populating it with a set of tasks. And now it's only reading the values that we're actually storing. Does that generally make sense, just how this local storage is working? Or what you're doing when you access that? Yeah, any questions?
So what happens in a scenario where you've got a commercial application and your user is actually blocking local storage? Because you can do that in the setting. So what's your workaround for that type of scenario? Or
I mean, obviously, in some sense, like this example is trying to do something very simple. So instead of setting up a backend where you're storing real data on the backend, this is just using local storage to make the tutorial easier. If you're doing a real commercial application, the vast majority of the time, what you would be doing for persistent type storage, it depends on your application, but the majority of the time, you're persisting your storage not to your browser, like the local browser, but back to a server somewhere. So somewhere entirely separate is usually where you're persisting something back to, and that's, unless they've turned off JavaScript, then that should be fine. Now, if they have disabled local storage, there are libraries out there, and quite a few of them, in fact. So if we hop on like NPM real fast, I mean, it might be better to look somewhere else because this might be hard to find, but So there's different libraries that you could leverage. Might be better for me to do this. Get my gist. So there's a lot of little bits of code that exist, like this one, which is going to try and use something like local storage if possible, and then it's going to fall back to cookies and other harder to manage methods if local storage isn't available. So if you're trying to store something local, there's a lot of different options for you, this just being one of them. Yeah, thank you. And it's probably, to be honest, if you were trying to build something that's robust, you'd probably want to use a library like this instead of directly writing the local storage, because not only is it going to help and make sure that it's using an option that works well for your platform, but it's also going to give you a much nicer interface for things like errors and issues. As was mentioned in this chapter, like local storage has like a certain limit, and if you're in like Safari and incognito mode, then it's not going to let you store anything. So there's certain settings and scenarios where you're going to have errors, and you would have to write code around a lot of those. But leveraging a library like this or other similar libraries, you should hopefully not have to write all that code yourself. That's probably what I would do if I was doing a local storage implementation for real in an application. But local storage would most likely also just be a fallback for storing something on the server. I mean, an example of something that probably does use local storage and only uses local storage. Here's an app that I use quite heavily, which is called devdocs.io. And this application, I don't have an account of any kind set up for this, but it's just a site that collects the documentation for a whole bunch of different technologies, and you can choose which ones to sort of turn on, so that instead of having to search around the different pages, I can search for documentation for everything, all of these right here locally. And you notice when I just logged in, it even gave me a little pop-up there. It was like DevDocs documentation just got updated. So if we go and look at our local storage, I've got documentation entries for all of the different things that I've enabled and set out. I care about seeing that documentation. So they're storing in sort of raw data all of the documentation for these things in a way that they know how to parse out and read. So I can say, let's look at the JavaScript documentation that they have. Get item, JavaScript. We can see a lot of information about this JavaScript documentation. Now, it doesn't include the actual content for everything. What it includes is just sort of all this metadata that it uses to search, and then the content gets rendered when you click on that piece of documentation. So there are some sites that, even though a lot of things would use a backend, a real backend to store that, there's good reasons to use local storage. Like this one's just nice and easy. So I never had to set anything up. I just choose some things. I never really clean it up, and it manages itself without any complexity on my part. Any other questions about local storage? So it also mentioned session storage in some of the notes here. And local storage and session storage pretty much work the same. So if we go over here and look at our session storage, we've got nothing there, but we can access it just like local storage. And we can put something in there, set item. And you'll see that we have a key with the value. It's really simple. The only difference between the two and this may not work because my browser session might maintain this, is that if I close my browser entirely so that it's going to lose its session. So it may keep this around even between this based off the fact that I didn't close Chrome entirely. Oh no, it didn't. Then your session storage gets wiped away. So that's a very temporary storage place. You can put stuff there if you need it while you're working, but let's just reset when we're done because this isn't something we're going to hold on to any longer than that. And you can see there's a few other standards here too that I'm not going to go into. Some of these were short-lived. Some of these are attempts to give something a little more robust than just a key value local storage data structure into the browser, something with a lot more capability so that you don't have to write a layer on top of it to do that, or that doesn't have the size constraints and other limits. But those are much more complex options in terms of actually implementing them. That's yet another reason to try and use a layer that sort of abstracts a lot of that away from you, because some of those may actually be better for the application in a specific browser. All right. Any questions on that so far? Mostly makes sense? Pretty straightforward, at least at that level. So where I think it gets a little confusing is sort of the way that we've implemented some of this local storage stuff in the actual application. So we're going to go ahead and walk through really these 3 files that we touched for the most part, and then we just cleaned up the notes storage a little bit. But 3 files that we touched and made real changes to, 2 of them new and 1 of them was a change. And hopefully that'll help explain that. And I'll also talk about some of the other files that aren't mentioned in this chapter that play a role in how all of this is working. So the first file that we created here is this applibstorage.js. And does anybody want to try and take a stab at just a high level what this is doing or what we're building in this?
So that's the part that gets the data from the browser and then it parses it into a JSON or an object. And then if you're saving it, it turns the JSON object into a string.
Yeah. So I don't know if we've talked about JSON in class before. Have we talked about JSON versus JavaScript objects? Okay. So that's one of the first things to sort of talk about here. If we go look at our local storage, and we can pull up this console again and do local storage.getItem app. And what we see here is a string. In fact, if we wanted to verify that, right, we could do type of, assign this to a value. We could do type of app data, and it's going to tell us it's a string, right? And this is what's known as JSON, which is, let me make sure I'm actually giving the correct term here. JavaScript object notation. And JavaScript object notation is just a very, this isn't the easiest thing for someone to read who's not familiar with grammar trees and stuff like that. But JavaScript object notation is a very lightweight data format is essentially what it's an attempt to be. What I mean by that is whenever you're sending data backwards and forwards between computers, whenever you're sending them data across the internet, you need to have some standard format that both computers know how to read. and understand, right? Whatever data you're sending, both systems need to know how to understand that. And one of the challenges is when you're writing applications, not everyone writes them in the same programming language. So you can't have, for example, you can't send a JavaScript object, a real JavaScript object over the wire and expect everything else to be able to understand that, because somebody may have their server running Java or Go or Ruby, so they can run entirely different servers. So what you need is some sort of generic way to send data back and forth. And there's a lot of different formats for this. In fact, that's what HTML is, right? We look at HTML, this is just a way of representing different data. And JavaScript object notation is just another way of representing data that maps very, very closely to an actual JavaScript object. The only real differences are it's a string at the top level, and every key for every value in your JavaScript object notation needs to also be a string. That's really the major differences between a JavaScript object and JavaScript object notation. Also, it doesn't hold any references to methods or functions or anything like that. It can only hold values that can actually be referenced. So strings, numbers, arrays, other objects nested inside of it. That's all that you can work with when you're sending JavaScript object notation stuff around. So then how do we take that in JavaScript, for example, and turn it into an actual object that we can work with? Because right now, even though I have this note store and settings store on here, if I tried appdata.noteStore, it doesn't have a property at all. It's just a string. So what we can do is use the JSON capabilities, which is a built-in library in your browser, again, that knows how to convert a JavaScript object to this JavaScript object notation, and from JavaScript object notation into an actual JavaScript object. So we'll do appdata_object equals appdata, or hold on, I need the JSON dot, and then there's really two major functions in this. There's parse and stringify. And what parse is going to do is take your JSON string and turn it into an actual object of some kind. So now if we look at our app data object, oh, this was double string. All right, we'll need to do this again because it was quoted twice. All right. JSON.parse itself. There we go. So now if we look at our app data object, we have an actual object with all of our properties in it and everything that we would expect. And now we can work with it like app data object dot note store dot notes. All right, that's the same type of data that we've had before, right? So go back to the code. That's sort of what this one part is doing inside of the get, and we'll dig into this a little more. And then the set is the opposite. The set is taking a JavaScript object of some kind, aka this guy right here, our app data object, and turning it into a JSON string that we can pass around. And the way you do that is use the stringify. So now let's clear our original app data so it doesn't have anything. So if we look at app data, oops, there's nothing in there. And now let's assign that the stringified version of the app data object. And what we see for app data is it's just, once again, we're back to that string of our object. So it's just a way to pass data around, but it's very, very easy to use in JavaScript because the notation almost perfectly matches JavaScript objects. So you don't have to do any real manipulation or conversion from one format to another. That's why it's gained a lot of traction as a data format. Does that make sense? So let's go back to this. We can actually pull it up in the code over here too. So again, this is this process of learning how to read code, breaking it down bit by bit. So if we look at just this portion, just this highlighted bit right here, what does that tell us we're creating here? What is that? Yeah, this is a function, right? And it's a function that takes a storage, some sort of storage argument. And then what we're returning from this function, again, this is this very dense syntax that the author really likes. What we're returning is another, or an object that has two methods on it, get and set. So this, what we're exporting from this whole file when we import this is a function that returns an object with two methods, a get method and a set method. And those are being used to access the data out of our local storage, to read it and to write it back into it. So they're just very thin wrappers around our local storage structure. Does that make sense? All right. One other thing I don't know if we talked about much at all is, does anybody remember what this is, this little bit of code is, this try catch logic here?
Is it like you try something and if it like passes, it goes on, but then it's not what it's looking for, rather than do like it just forgets it somehow?
I think that's a pretty good explanation. This is what's known as like error handling code around errors being thrown inside of the programming language. So in other words, this is a way to protect you so that your program doesn't crash if an error happens, essentially. It's saying, we're going to try and do something that has a chance to produce an error. And if that does produce an error, in this case, we're saying we don't really care. I don't care what happens. And that's just because we're not going into the details of implementing proper error handling and how to deal with that in this tutorial. But this is just a wrapper around, oh no, I'm doing something that could produce an error. So an example might be, five equals app data. That's an error, right? Uncaught reference error right here. Because it's an invalid piece of code. It's something that you're not supposed to be able to write. And if you know that something that you're doing has a chance to produce an error of some kind, you usually want to wrap it in a try-catch block so that your program doesn't just crash when it encounters it. So how you could do that with something like this. Now, of course, in this case, I'm forcing an error. We know that this will produce an error. We can say try 5 equals app data. We know it's going to produce an error, but then we can catch that error and do something with it. And in this case, let's just log the error. In fact, we'll even log it the same way that an error actually gets logged. We'll say console.error to log it. Oh man, it didn't even log my error. What's going on? I don't know. Let me try it. I expected that to throw my error. Oh, I'm double equals. I'm not trying to assign a value. That's what's wrong. All right. So what should be happening here is it's trying to do some sort of logic and then it's catching the error and doing something with it. I don't actually think it even let me do that in this. The logic might have been so bad that it just blew up despite my my little bit of error handling. So let me see if I can think of a better example of one. I can throw an error that's more predictable. Gives me infinity. I don't even know what to do.
What do you do?
I'll just throw one. I'll just do it.
You can check if something's true or false.
What?
Check true or false.
What do you mean?
Or you can say true or false. Here.
Well, I'm not going to throw an error that way, though. All right, I'm just going to throw an error. I'm going to manually throw an error. Let me make sure I've got my syntax right, too. It should be right. I catch my error. There we go. So that one didn't completely blow up. So what happened was I wrote this like throw error line, which is forcing an error in my code. And since I hit an error, it ran this catch block to say, all right, this is what I'm running instead of just erroring out. Whereas if I did that without it, and I had like, let's just do a little block of code here. And we'll say console.log start, throw error, console.log end. You can see that start ran, but end never got logged because that error just kicked me out of my code. It was like, there's an error and I don't know what to do. The only thing I know how to do is exit. So basically what we're doing with this little bit try catch is saying, if something goes wrong when we try and parse the JSON data out, we don't really care about it. Catch that, but don't throw the error any farther up the stack. So nothing else needs to know that an error occurred. Just keep running the application like usual. This isn't, again, ideal error handling. It's just a way to work around the possibility that one of those errors could pop up without actually writing all the logic to handle the different types of cases that you would want to handle. So how are we feeling about this storage.js file now? What? Better? That one makes, this one's probably the easiest one because it's really standalone. It doesn't tie into other stuff as much. So now we can see, he even has a reference, there we go, to another library, local forage, as a way to try and support all these different local storage options. So that's another wrapper around it. Again, an example of the fact that you're not really going to be implementing this from scratch usually in your own application. So the next thing, and this is where it got a little magic, if you will, it talks about persisting the application using final store. And it even sort of mentions like, oh, we already have a final store and we're just going to leverage that and we're gonna do some snapshotting and bootstrapping and bada bing, bada boom, you're done. And you're like, okay, I didn't follow any of this. What is he talking about, right? So let's look over a couple of these other files that we had already written. And again, we're not going to go into all of the detail of how this stuff works. It's complex interactions. And that's one of the reasons that some of this can be glossed over. But we want to make sure that we know that it's not just magic coming from somewhere else. That this stuff has been implemented. There is support for it coming from somewhere. So if we look at this top level alt file that we wrote, which is sort of setting up our alt store, we're creating this new Flux store. Well, we're creating a Flux class which extends alt. We're calling the alt constructor, and then we're calling this dot final store equals make final store. So we're assigning into this final store property of our Flux store or our alt store something that we're getting back from this make final store function. Now that's just coming from this magic alt-utils library that we're not going to really dig into or explain, right? But this gives you some capability to do this sort of final store structure. So where are we actually using this final store structure? And where did that come from before this persist? Well, if we go over and look at our connect, which again, we've glossed over this a fair bit because we don't need to go into all of the details of how this stuff is structured. But this connect function, one of the things we do is we get flux out of our context. This is all just sort of getting stuff out of our React components. And when we get flux, what that is a reference to is this alt object here, and this flux object. And this flux object has a final store property on it, which again is just another object. And that lets us do things like listen and unlisten. And listen and unlisten are just, this is what's known as the, I can't remember if we've talked about this here, but this is one sort of implementation of what I call the higher level general sort of pub sub model, publish and subscribe. So what's going on here is this final store has a method called listen. And that listen method takes an argument for what it wants to listen to. In this case, this handle change object. And it's going to listen for when this guy essentially gets called or used, when it gets invoked, and do something when any of that's going on. So it's handling the changes, and then it's unlistening to the changes when we unmount our component. So this is the way our component's getting hooked up, so that when something in our component changes, we're changing our flux store, and when something in our flux store is changing, we're updating our component. It's this sort of listen pub sub type model, if you will. Again, this is all a little bit magic. We can implement something that doesn't have this level of complexity to sort of talk about this publish subscribe type approach, but it's very, very similar to having event handlers on different things in the DOM, right? Like you have a click event handler. This is very similar. It's listening to changes for whatever you're hooking up to. So those are the two pieces that already existed in regards to this final store before we wrote persist.js. So while he's talking up here, he's saying, oh, we already have this final store component. We do already have some logic around that. It's just something we did. I mean, you know, given that we've had a long break over the holidays and everything a while back now, so it's easy to forget where that came from. And we sort of glossed over some of it as well. So given that, we can now look at this persist.js and try and break this down. Again, it's useful to think about stuff in these sort of smaller blocks and pieces. So this is a function that takes 3 different arguments in. It takes alt, which let's assume I haven't looked any further down in this tutorial at this point. I'm going to make an assumption like that's probably my implementation of my store that is taken as a parameter. I don't know. I'll take a guess. It takes storage, which that's some sort of storage object. And since it looks like it models, we've got get and we've got set, since it looks like it has the exact same function names as this storage object we've already created, I think it's safe to assume that what we're going to be passing in is that object, or yeah, the object that gets returned from that function. And then it takes this storage name parameter. And right now, all right, I don't know exactly what that does, so let's look around a little bit. Storage.get storage name and storage.set storage name is the first parameter. So if I were to step back at storage.js and look again, that looks like it matches these parameters to this guy. And if we go back up and look at the documentation for local storage, that looks like it sort of maps what you're expecting when you call get item or set item. And since we already played around with that a little bit, we can probably say, oh, that's probably like the key is what that parameter is. So that's telling us what the key for our storage is going to be. What name do we want our storage to have where we store it? And then we can get down into the details here where, again, going back to the book, we've got some magic going on. So it talked about we've got snapshotting and bootstrapping. This is something that's coming straight from Alt itself as a way to pre-populate your store with some data when you're running the application and a way to save the state of your store somewhere else. So these are capabilities built into this Alt framework. And basically what these sort of functions mean is when it says bootstrapping, it's saying, all right, if I've created a, when Alt spins up initially, just like anything else, all it has, it's just an empty object or an empty store. There's nothing in there. So how do I populate it with some content? Well, I can call this bootstrap method and give it some other object. In this case, we're getting that object straight out of our storage. And basically, it's going to put that object into our Alt store now. So that's what we start with when Alt is starting up. So that whenever you're starting up the application and Alt code, this sort of Alt code runs for the first time, one of the first things it does is it bootstraps and puts this data into that Alt store before anything renders with that data. And that way, you already have your data in your application, and any changes you're making are against the data that you actually want to make. Does that generally make sense? And the snapshot is just sort of the reverse. It's a way for you to read the current state of Alt and turn it into, just get an object out so that you can do something with it. It's like, maybe I want to, I don't know, copy it somewhere else. Maybe I want to manipulate it outside of Alt. Maybe in this case, I want to persist it into local storage. So in order to do that, I just do alt.takeSnapshot, and I'm able to get the current object that represents all of that Alt state and do something with it. Is this a little better now, this persist file, in terms of what it's doing? And again, and I glossed over it, we've got the try catch block, right? But another example of doing something if we're spinning up the application. And so here's where we should be able to, let's see if I can do this. What's this, how do I do this setting? I'll have to look this up. All right, so let's see here. Let me see if I can get this set. I don't know if I can. Going to, no. This is gonna be pretty old. This probably doesn't even exist anymore. It just takes me back to here, huh? All right.